In this lesson, we are going to learn how to reduce rational expressions. It starts out by going back to learning how to reduce fractions. At this point in your math career, you just look at the numbers and say, oh, they're both divisible by 6, and you reduce. But how did you learn that? Well, at some point, you had to learn about factoring, writing out some factors of 18. Now, there's lots of different ways we could write that, but what if we wrote it as 6 times 3? And then 30 is 6 times 5. What allowed you to reduce it is that you divided out the common factor of 6, because that goes in there one time. And that's why when you reduce 18 over 30, you get 3/5. Reducing common factors. And remember, factors are things that are multiplied together. So what would be wrong, something you couldn't do? If you had 18 over 30, you couldn't say, well, that's 12 plus 6 over 24 plus 6. Cancel that out. And so, oh yeah, that's 1/2. That's just wrong. You cannot cancel out common add-ins. Really, that's what that is. Wrong, 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 wrong. You have to have factors, things that are multiplied, then you can cancel or reduce or divide out. So, what is a rational expression? It is a quotient, meaning there's division, of two polynomials. All that's vocabulary we have learned in the past. In other words, we have a fancy schmancy fraction. How are we going to reduce them? You're going to factor, and then you are going to divide out common factors. So here comes all that factoring that we've learned. So number one, you cannot just start reducing. Can you factor the top? No. So I'm going to put that in parentheses to say, hey, that's a factor. How do you factor the bottom? That's the difference of two squares. Then, because x minus 3 and x minus 3 is a common factor, I can divide those. That goes in there one time. So my answer is 1 on top of x plus 3. You could leave the parentheses or not, doesn't matter in this particular case. I'd rather be safer by leaving those parentheses there. Looking at number 2, can I factor the numerator? Yes, it has a GCF of 4. So if I divide both by 4, I get that. That stays the same. Then one more time, those are common factors, so I can divide those out, and I'm just left with 4. Factor, factor, factor. Look at number 3. Well, what does that have? They have a common factor of 7. On the bottom, they have a common factor of 2. And I might say, well, I'm done. Nothing's the same, so I just leave it. No. What can I do with that? I can factor it more. That's the difference of two squares. So I'm going to leave the denominator the same because I can't factor it any further. Now I have common factor of x minus 2 and x minus 2. Those reduce, meaning they divide to 1. So on top I have this, on bottom I have that. Factor, factor, factor. Number 4, getting into trinomials. The good news is they have coefficients of 1. So I know it's x times x. Again, we say what multiplies to get positive 15, adds to get negative 8. That's right, negative 5 and a negative 3. On the bottom, again, leading coefficient of 1. So what multiplies to get negative 6 and adds to get negative 1. Negative 3 and positive 2, right? We need a negative and a positive to multiply to get negative 6, add to get that negative 1. common factor of x minus 3, so we can divide that out, and I'm left with x minus 5 over x plus 2. So as long as the factoring's easy, it's really pretty easy. Okay, number 5, I have a monomial on top, so I know I can't factor that. On the bottom, I have a GCF of 8x squared. So if I divide both of those by 8x squared, that's going to leave me x minus 4. I cannot factor any further, and they have a lot of common factors. The 8, the x squared, those can reduce. 8 goes into 8 one time, x squared goes into x squared one time, so we're left with 1 over x minus 4. Don't forget that 1. That's very important when it's on the numerator. Alright, number 6. Well, those all have an x, so let's take out that x. And that leaves me with a trinomial that I'm going to go back and factor in here in just a second. Those also have an x. And remember, x goes into x one time. So right here, I could reduce and say, well, you know, those x's are going to divide out. And that's true, so now I have this over that. Would that be my final answer? Probably not. I think I could probably factor that more. So, my only choice for 3 is 3 and 1. My only choice for 5 is 5 and 1. I got to play around with it to get an 8. Why don't you pause the video, see if you can factor both of those. Alright, have you factored them? Let me give you a hint. If you get stuck on one trinomial, try the other. Or if you have one and you're stuck on the second one, most of the time these problems are designed where something's going to be the same. So as I looked at this one, I got that one fairly quickly. I had a little bit harder time with that one, but I knew it couldn't be with the 5, so I'm kind of going with the x minus 1. Again, you can use one part of the problem to help you figure out the second part of the problem. Alright, let's keep going. We can reduce because those are the same. So my final answer is 3x minus 5 on top of 4x minus 1. You don't have to put those parentheses. The answer might not have them, but just going to put them just to be safe. The next part of our lesson, we need to look at opposites. So 5 and negative 5 are opposites because if I take 5 and multiply it by negative 1, I get negative 5. Which means when I divide 5 by negative 5, I get negative 1. If I take negative x and multiply by negative 1, I get positive x, which means if I divide them, again I get negative 1. If I multiply this by negative 1, let's see, I get negative x plus 2. Is that the same as 2 minus x? Yes, it's just written in a different order. So again, let's just be real clear. X minus 2 and 2 minus x are indeed opposites. And when you divide opposites, you get a negative 1. So if I multiply this by negative 1, I get negative 4 plus 5x, which is again the same as 5x minus 4. Look at that, 4 minus 5x minus 4. When I reduce that, I get negative 1 when you divide opposites. Those are both opposites, that's the same, and we divide and we get negative 1. Now let's just take a minute and look at what are not opposites. What are not opposites are things like x plus 3 and x minus 3. Those are not opposites. Yes, the 3's are opposites, but not the x's. In fact, they're not opposite. What are these called? Conjugates. Not opposites, but conjugates. So when we're dividing out opposites, we get a value of negative 1. So let's look at these problems. Are those opposites? Yes, they are. So when I divide them, I don't get positive 1, I get negative 1. Let's look at this next problem. I need to factor, so I see a common factor of 4x. On the bottom, I see a common factor of 3y squared. Then I ask myself, can I reduce? Those are not the same, but are they opposites? Yes, they are. So when I divide them, I have a factor of negative 1 left. So this is negative 1 times 4x over 3y squared, which is negative 4 over 3y squared. Now let's look at number 9 and 10. They look kind of the same, but they are a little bit different. So number 9, we need to factor the top difference of two squares. The 25 comes first, so put the 5's first. Then it x's, 1 plus 1 minus. Those are conjugates. On the bottom, I have a trinomial with the leading coefficient of 1. So what multiplies to get 25 and adds to get 10? Plus 5 and plus 5. And yes, that is also a perfect square trinomial. Do I have any common factors or opposites? Well, this and this. Those are not opposites. Those are exactly the same. Exactly. You can add in different order. So when I reduce that, that goes in there one time. Here's my question. Are those opposites? No. The x's, one's positive, one's negative, but the 5's are both positive, so those are not opposites. So my answer is just 5 minus x over x plus 5. That's it. Now let's look at number 10. Looks the same. We have the difference of two squares, and the 9 is first, so I need to go with the 3's. 1 plus, 1 minus the conjugates. On the bottom, again, I have a trinomial with a leading coefficient of 1. So what multiplies to get negative 18 and adds to get positive 3? A positive 6 and a negative 3. Do you have any of the same factors on top and bottom? No. But those are opposites. The 3's have a different sign, the x's are a different sign, so those are opposites. So I can divide those and get negative 1. And this is where putting parentheses really makes a difference. So we need a negative 1 times 3 plus x over an x plus 6. Or we could write it like that, because usually we don't write that 1. Now I guess I should be careful, put everything in parentheses. And that's probably the safest way to write that answer. Don't leave out those parentheses. Let's look at 11 and 12. Ooh, 11 a little more challenging as far as those factoring. So let's look at this. Is there a GCF? I know they have an x cubed. What are all those numbers divisible by? I hope 6, so I'm thinking 6x cubed. So that leaves me x squared. 6 goes into 54, that's 9. That leaves me an x. And that would be positive 20. Wow, that looks a lot easier now. Down here, I think they're all divisible by 3x cubed. And let's see, that leaves me that. Alright, I need to keep factoring those trinomials, but could we kind of reduce right now? Let's see, 3 and 6 reduce, that reduces, so let's see if we can do a little reducing. 3 goes into 6 2 times, and the x cubes would reduce totally, so I have a 2 left on top. Then I need to factor those trinomials. So the good news is that's a leading coefficient of 1. What multiplies to get negative 20 adds to get negative 9. On the bottom, leading coefficient of 1. What multiplies to get negative 15, adds to get negative 2. Do I have any common factors or opposites? Common factor, exactly the same. Those reduce, divide in there one time. And so I'm left with 2 times x minus 4 over x plus 3. No opposites, but a lot of factoring. Last example. Well, that top part looks pretty easy. So let's see. I have a leading coefficient of 1. What multiplies to get negative 3 and adds to get negative 2? Negative 3 and positive 1. On the bottom, these are cubes. We don't get to practice those very often. Remember, a cube has a short one and a long one. Binomial times a trinomial. So let's do the binomial. Remember, we keep the sign. What times what is 27? Then that leaves me x. Then I have a trinomial. We square that. We square that. Remember, it's always positive. We multiply and change the sign. Now, do I have any common factors? Are those the same or are they opposites? They're opposites. So I can divide, and that leaves me a factor of negative 1. So I'm just going to write it as a negative times x plus 1, put those in parentheses, and then I have that on the bottom. So reducing rational expressions really challenges all of your factoring skills.